Great, so welcome everybody. Good to see you in person and online. I'm going to be talking today about ways that generative AI can be used for a whole range of different software-intensive and software-reliant system capabilities. And first I'm going to channel my inner Socrates, who said, "The unexamined life is not worth living." I'm not sure if he said that before or after "I drank what?" which is actually the real title of this slide. So my slogan is "The unrecorded talk is not worth giving." So I'm recording this talk, and I will give you guys the link to it when we're done. So what I'm really going to talk about is assuring the future of software engineering and AI engineering, and there's an intentional pun here, which we'll talk about as we get a little further along. My whole encounter and my whole exposure to these topics began several years ago. We were working since around 2020 or so on a national agenda study that was sponsored by DARPA and Sandeep and National Science Foundation and Saul Greenspan and the Software Engineering Institute, where I used to be the CTO and I still do a lot of work. And we were trying to figure out what's a roadmap, what are things going to look like for software over the next 15 years or so. And we came up with a whole bunch of cool things, most of which I will not talk about. I'm just going to focus on two things, but you should take a look at the report. It's kind of interesting, and it tries to predict what will happen down the road. And we'll see what becomes true or not, but it was a good exercise to think outside the box. The focus was to look down the road, so sort of a DARPA thing. We're not just looking 6 months down the road or a year. We wanted to look 10 to 15 years, and that's important for a reason we'll see in a second. One of the things we came up with, because we were trying to look down the road so far, we said, wouldn't it be great if at some point in the future, humans and AI could work together as trustworthy collaborators? And we thought that's a really far out thing. And then literally 12 months to the month after we released our report in November 2021, ChatGPT escaped from the lab. So all of a sudden, our time frames were thrown into disarray. And as I'm sure all of you know at this point, unless you've been frozen in carbonite like Han Solo, ChatGPT and similar large language models are ways of trying to be able to generate what appears to be, and actually in many cases, in fact, is creative content in all kinds of modalities. It started out mostly being text-based. Now it's image-based. I'll show you some fun examples. And something else that has just happened very recently, you can actually give it images and have it analyze the images, which is absolutely fascinating. It's very, very good. Its attention to detail is game-changing. So that's the way things were. Gosh, it's hard to believe that hasn't even been a year. I think it came out on November 30th. So it was about a year ago when it came out. And of course, immediately after the release of ChatGPT, all the pundits started to decide that the world was coming to an end. So if you Google, "Is AI the end of the world?" you will find all these links to articles talking about how are we doomed, AI apocalypse, AI will destroy humanity, the end of humanity, and blah, 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 blah. So if you've ever seen the movie, I think it's Anchorman with Ron Burgundy, there's a funny scene where he says, boy, that escalated quickly. So this is kind of what's happening. Now, the good news is if this is in fact the end of the world, we don't have to think very hard about predicting what's going to come down the line in the future, right? It kind of cuts off our need to think down, very far out. However, I personally don't believe it's coming to the end of the world. Other things are much more likely to cause the end of the world than generative AI, quite frankly. And in fact, if you think back, gosh, what was it? About 59 years ago, 58 years ago, there was the famous Dr. Strangelove movie where they were living in the shadow of atomic fear, and the movie was about how to stop worrying and love the bomb. Well, I've decided I'm going to stop worrying and I'm going to love the bot. So that's what's going to happen. So what I'm going to do is focus in on two of the topic areas from our study. If you look at the study, two of them dealt with AI augmentation. And there was AI augmentation in terms of developing software, the software development lifecycle, and there's also AI augmentation about actually running systems. So systems operations, system development. And after we released the report and we started actually looking at what ChatGPT was doing and other generative AI techniques, we really realized that those things are not unrelated. They're part of a quadrant, if you will. This is my DARPA training coming into effect, where you have degree of AI augmentation in the software development lifecycle from low to high, and the degree of AI augmentation for system operations, low to high. And we put out a blog posting a few weeks ago from the SCI talking about this, and I will go into it in a bit more detail. 99.9999% of all systems that are out today, especially the ones that we care about here, the mission critical systems, are built using no AI in the development and no AI in the runtime. So I've done lots and lots of work in avionics mission computing and other mission critical systems where the answer delivered too late becomes the wrong answer and so on. The right answer delivered too late becomes the wrong answer. And these systems are not built with AI. And up till very recently, there was good reason because people couldn't get it to work at scale and they were nervous about how it worked. One area, which I'm going to focus on quite a bit in the first part of this talk, is building conventional systems using AI-augmented software development methods, tools, languages, techniques, and so on. Simple example, you can see more about this at this link. When I teach my classes at Vanderbilt, we built a lot of mobile apps and server-side components. And now, since the last 18 months, or not, more like 9 months, we've been using AI-enabled techniques to build those systems. But they're not AI-enabled systems. They're mobile apps that happen to use AI techniques for things like augmenting the code reviews, generating test code, generating scaffolding code, generating code, doing the tests, et cetera, et cetera. At the other end of the spectrum are AI-augmented systems built using conventional techniques. And a great example of this, not necessarily as interesting as some of the things that we might work on in this context, but more broadly, something like YouTube, which has got all kinds of AI-augmented things for deciding what videos to show you, deciding what ads to show you, and so on and so forth. But as far as I know, the software itself is built in conventional ways with whatever it is that Google's doing these days. And of course, where we're headed with this, and this is the 10 to 15-year goal, is to build high-confidence systems using AI-augmented techniques that use AI. So a self-driving car that uses machine learning for navigation and decision-making, built using AI-augmented tools. That's sort of the pinnacle of where things are going. And we'll be talking a lot about that in the future. I'm not really going to focus on that yet because I think we're not there for all kinds of obvious reasons. One of the things to note about generative AI is how low the barrier to entry is. So you can use ChatGPT, you can use Claude. I wouldn't recommend using Bard yet. It's very much in its infancy. I think Google's coming out with something called Gemini soon, which should be a heck of a lot better. But ChatGPT, Claude, they're both good. And for the low price of several cups of expensive Starbucks coffee, pumpkin spice, I think, is the most expensive coffee at the moment. For like 3 cups of coffee a month, you can get access to the better version of all this stuff, which does a lot of really, really cool things. However, it's important that we set our expectations appropriately. So if you read articles, there's a bunch of articles from famous computer scientists, my colleagues, our colleagues, Peter Denning, Bertrand Meyer, who have done some preliminary, and I would say somewhat superficial analysis of these tools, and they've come up with these prognostications about how limited and bad they are. I'm not entirely sure why they do this. I think it makes people feel good to think that they can still beat computers at something, since they can't beat computers at chess anymore. You can't beat computers at Go, but you can still, do a proof or whatever. You can do a proof better. So if you read the articles, it's pretty funny. Peter Denning has this article from CSM where he talks about what you get out of a chatbot. Most of what it tells you seems like you've already heard it somewhere before. No radical departures from what others have already said. Frequent incursions into nonsense. Speaks with great authority even when outputting nonsense. That sounds like me my first semester as a grad student. And my advisor would probably say the same thing. The difference, of course, is nobody expected me or any first semester grad student to write papers for science and nature that get accepted, to write DARPA or NIH or NSF proposals that are going to get funded. We work with our students, we get better, we make them smarter, they think better. That's a better way to think about stuff. And in fact, going one step further, generative AI should really be perceived as generative augmented intelligence rather than artificial intelligence. Augmented meaning there's still a person in the loop. The person is being supplemented by this technology, not supplanted. We're not trying to replace people. And once you pop your mind into that perspective, it's much, much better. And we'll talk more about specifically how to do that when we talk about prompt engineering, which really gets you in the loop. And the better you prompt engineer and the more context you give, and if you use the right tools in the right way, you get great results, which undercut the gloom and doomers who haven't been able to be very successful so far. So one way to think about this stuff, for those of you who are fans of the X-Men series, it's like cerebrum. It's like an exoskeleton for your brain to help you think better. So let's start by talking about the situation that I'm going to focus on, which I think is very, very promising, which is using AI-augmented techniques to build conventional software. So I'll start out with a high percentage shot. If you remember Dr. J from the Philadelphia 76ers, he loved to dunk. The reason he loved to dunk was dunking was a high percentage shot. So the sort of obvious thing to say here is generative AI is and will continue to have a transformational impact on the way we build software. Why is that the case? Well, it helps to offload cognitive load from developers. And I do this all the time now, and it is so amazingly cool. So we'll talk more about the ways you can apply it than just building software. There's a lot more to building software, as everybody knows, than just writing code and debugging code and so on. And if you take a look around, there's a whole slew of tools, some of which are free, some of which you have to pay a nominal amount for. Again, a couple of cups of coffee at Starbucks a month. I use Amazon Code Whisper, which is free. I don't know if it's the best, but I use it because it's free. But I've heard a lot of good things about GitHub Copilot, Tab9, Android Studio Bot. They're all coming out with the same stuff. I would expect in the very, very near future, all IDEs will come out of the box with this stuff, perhaps bundled in with the subscription fees that you pay. And it's really, really useful if you spend a lot of time writing code, which I do. So I've been applying these tools to my upper level courses at Vanderbilt. You can take a look at this video if you want to learn about the education aspects of this. The one thing I'll note is I teach upper division courses, so we already have people who know how to program. And that's important because you can also use these or misuse these tools in a way that outsources your brain, and you never learn to develop the basic skills for programming and problem solving and detecting when things are going off the rails. I worry about that. I'm very bullish when I think about people like us who have experience. We are going to be way more productive, but not everybody has the benefit of a lifetime of doing it the old-fashioned way that they can build on. So again, you can take a look at these videos, links, and I'll put out the slides. You can click on, they're all clickable links. Once again, not everybody is bullish on how effective this stuff is for programmers. There's a famous computer scientist, Bertrand Meyer. He was a software engineer, professor back in the day, did a lot of work with object-oriented design and programming back in the early 80s. He's the developer of the Eiffel programming language. Good guy, knows a lot about programming, completely misses the point with AI. If you look around, if you remember famous quotes people wish they hadn't said, one of them was by Thomas Watson, one of the founders of IBM, who in 1942 said, "There's only a market for 5 computers in the world." Probably somebody wishes he had taken that one back and hadn't said it. Another quote I love is Bill Gates, "Who needs more than 640K memory?" If you remember that one. And Bertrand Meyer, "AI does not help programmers." That is simply not true. And I wish he hadn't gone on record saying those things. I know why he said that stuff, but it's wrong. And there's 3 reasons why it's wrong, or it indicates 3 things. Number one, if you don't use the right tools, you will get the wrong results. For example, if you stick with using ChatGPT 3.5 versus ChatGPT 4, you're more likely to have things that don't work. If you use the tools in the wrong way, there's different ways to use them. You can cut and paste things into the chat window. You can use a file-based interface called the Advanced Data Analysis Technique, or ADA, which is kind of funny. That doesn't work as well for various reasons. So there's limitations that you just have to use the tool in the right way. And then I think the most important thing is if you don't program every day, it's a lot harder to understand why these tools are useful than if you do program every day, because you find out how it works in your workflow. I think a good analogy for this would be, imagine if Michelangelo had come along to his first block of marble and he took his chisel and he hit it once and it didn't turn into the Pieta instantly, and he threw up his hands and said, "See, sculpting is not for me," or "My chisel doesn't work," or something. You have to hit these things with more than 1 or 2 whacks to get them to do something sensible. So let's talk about some R&D challenges and opportunities in the space of using tools to build conventional software with AI flavor to them. So here's some interesting things, and this hopefully will resonate with folks in this community. So you use LLMs that have largely been trained on Stack Overflow and GitHub. Now, they do a remarkably good job often, but they were trained on Stack Overflow and GitHub, so there's going to be all kinds of weird things that people do. And I'll talk later about how to prompt engineer your way to a better solution too. But with the early versions of ChatGPT 3.5, if you didn't have the right prompting and you used the wrong tool in the wrong way, you would often get gobbledygook as output, or you would get output that had vulnerabilities in it. And so people had highlighted that as, once again, computers can't keep up with people. So obviously what we need to do is train these things on better vetted code that's more robust, and in some cases perhaps specialized code bases. Because otherwise, if you put spaghetti in you should not be too surprised that you get spaghetti out. So let's take a look at some examples that have come out recently. So there's something called CodeGen from Hugging Face, which I think is a very whimsical name, but they're very well regarded in the machine learning and deep learning and transformer community. They built a so-called autoregressive large language model, we'll talk about what that is in a second, that's been trained on lots and lots of code with Python, JavaScript, Go, and so on and so forth. And so for programmers, that's a pretty useful thing because it's been trained on things that are hopefully in pretty good shape. All autoregressive means is that the way the tools are trained, it's very brute force. You may know this, but basically it takes lots of text, starting either with human text like the works of Shakespeare or program text, and it goes through and it removes certain words, and then it tries to build up a percentage map of what's likely to occur, what's most likely to occur as you start trying to replace the words. So if you say the Trevi Fountain is in the center of, and you remove the thing, if you train it long enough, it'll figure out it's probably Rome, not Buenos Aires. There may be a Trevi Fountain there, but it's not nearly as famous as the one in Rome. So that's how they work. There's a lot more, though, that we'll talk about in terms of how things work in a second. But that's the basic out-of-the-box stuff. Not surprisingly, tools like CodeGen, and also, quite frankly, large language models in general, tend to work best for mainstream languages because that's what they've been trained on. And while they do a remarkably good job of being able to move between languages, like the other day for no particular reason, I had some Java code and I wanted to see if it would generate the Ada equivalent. I learned Ada back in 1986, and I haven't touched Ada in like a very long time, 30-some years. But I wanted to see if it could do it, and it did it instantly. It would have taken me weeks to figure out the same thing, but it did it instantaneously. But you're going to get the best results with mainstream languages. However, not everybody works in mainstream languages. Not everybody has the luxury of working with, or the pain of working with JavaScript or whatnot. And there's certain domains, especially in the DoD, and any older legacy system, a lot of government programs, that have more stringent or unconventional quality attributes. So mission and safety critical systems. I do a lot of work with nuclear weapons safety and some weapons programs. There's specs that you're familiar with if you work in this world, like the Air Force Manual 91-119, which tries to codify the processes and rules and guidelines by which you should build nuclear sure code. Remember that, because we're going to come back to that in a second. There's also lots of legacy systems out there built in very weird non-mainstream languages, Jovial and Ada again, COBOL, which is pretty funny because if you look at this, it was sponsored by the Department of Defense back in 1960, 60 plus years ago. But it was a DoD language at one point, developed by the Commodore, right, or in collaboration with Grace Hopper. So what can we do in that space? Well, we can obviously do ourselves a lot of favors by building customized trained data sets to help with the sustainment of these legacy languages. And if you think about the depots, if you think about people who work for the Air Force or other places, such as Tinker or Warner Robins, Ogden and so on, they have a lot of work on their hands to take these legacy databases. Nobody teaches that stuff in school anymore. Nobody remembers it. Everybody's retiring and so on. So that would be a very low-hanging fruit for DoD stuff to have specialized tools that work in these older languages. More generally, however, we really need to start thinking about how these tools can help us re-envision the software development lifecycle. And I assume you all know what that means. There's tons of data throughout the lifecycle that doesn't necessarily have much to do with code. There's all kinds of other artifacts. One of my colleagues at the SEI, Robert Nord, or Rod Nord as he calls himself, wrote a very interesting article recently where he talks about using machine learning to look through GitHub repositories at things and Jira issue tracking databases to try to identify technical debt so that people could identify where it was occurring based on other things besides just the code, like the comments and so on, and then prioritize where to focus to pay down that debt. So I thought that was pretty cool. More generally, there's all kinds of other artifacts, as we all know and love or don't love. For requirements, there's meeting notes, there's discussions with customers, there's discussions with people in the teams, all the wonderful diagrams, UML and so on we have for trying to show the architecture of the system, testing, test plans, test results. Very important if you're doing a DevOps style model to see, am I converging? Are my bugs getting lower? Are my bugs getting higher? Where are my bugs occurring? People can do that stuff, but it's not something people do a very good job at scale. Deployment, software as infrastructure as code, and then all kinds of other things you do in agile processes. So This is something where the AI tools, the AI plus, the augmented intelligence, can actually be much better, faster, cheaper than humans. And in fact, I think one reason for that, and why I think it's the sweet spot for the moment, is if you look at coding and testing, the criteria for success is pretty much perfection. And so one of the reasons why people like Bertrand Meyer and others have criticized LLMs is they're not going to guarantee perfection. So if perfection is your baseline, if that's the gold standard and you're 85 to 90% there, it's just not good enough. Imagine if you had a compiler that would compile really good code very quickly, but it would be right only 98% of the time. You probably wouldn't want to use it, right? You couldn't trust it. So maybe that's not the place to start by trying to replace people. Maybe a much better place to replace people or augment people is all those other steps in the software lifecycle where utility and usefulness is more important than perfection. And it's mostly these higher level tasks. So think for a second, going back to our friend, the AFMAN 91-119 spec, and we actually did this recently, myself and some colleagues at the SEI. We're working on a program with people, 2 programs that have to use this very carefully. Really smart people have thought about these things for a really long time. This document, if you look at it, it's from 2012. I don't know what revision that was, but this has been around for a while. In fact, a lot of the techniques have been around since like the 60s and 70s, if you think about how they build nuclear safe code. You might think that after so many smart people have looked at these documents for so long, they would be free of inconsistencies and gaps. But you would be wrong. And so what we did is, because they're public documents, we put them into ChatGPT and we asked it to do discrepancy analysis, look for inconsistencies between what is in this document in terms of itself, not in terms of it and something else. Like, is there guidance? And classic inconsistencies occur at these boundaries between different disciplines. So if you have, for example, the safety engineers, what's their mantra? Don't change anything once you've verified it. Then you bring along the security engineers. What's their mantra? Patch every single day, right? Because they're in conflict. So it would be no surprise that you would, in fact, find inconsistent guidance here. So we've started to do discrepancy analysis with our simple tools off the shelf. I'll talk in a second about how to make these much better. But I think this is a very promising area, discrepancy analysis in general, for AI, for software engineering, for the legal profession, for people who do audits. Almost anything where you have to compare and look for differences, people don't do that very well at scale, right? If you have this is a pretty large document, and it's only one of many documents you have to be responsible for conforming to if you want to build nuclear safe systems. People cannot read this. If you've ever had, as I'm sure many of you done, read large documents, hundreds of pages written by dozens of people, after like page 32, you cannot remember everything that went on. But these tools do a much better job. They're much more thorough. They're like the Terminator, right? They don't have to eat. They don't have to sleep. They will not stop. They're relentless. So along those lines, something else that's very promising that's just come out very recently is integrating the chatbot technology with other tools for document processing and retrieval. And this has led to 2 things that you really need to be aware of. One is this concept of LangChain, where you can take the LLM and rather than expecting it to do all the pieces that you want it to do, you have it basically outsource some of its processing to very specialized models that do high fidelity, high accuracy type of analysis. So a good example would be, when you need to do your proofs, you don't rely on the LLM to do the proofs. You basically have it call out as a subroutine to something that's a proof system, like Wolfram Mathematica or AlphaGo or whatnot. That's part number 1. Part number 2 is to take LangChain-like tools and then combine them with something else that's fairly recent called retrieval augmented generation, or RAG. And this is something that IBM has gone all in on, really cool. And what they do is they're taking all their documentation for all the products. You can imagine IBM has a huge corpora of documents. And they're taking all their documentation and they're building models using this RAG technology, which is a little different from an LLM in the way it's trained. But basically, it encodes vector spaces for each document and each piece of each document. And it does it in a way which will fit into the context window of the LLM it will be used with. And so they build these things, they put them into vector space databases like Pinecone. And then when a user asks a query, it will go and look up in those knowledge bases to find the match. And then it'll take the results and run it through an LLM to get the chat part. So you get the conversational aspect of a chatbot with much higher precision from using better, more precise lookup techniques, which are still very cool and very AI-ish, but they're not as prone to hallucination as the LLM because you're actually going from documents that themselves are self-consistent rather than expecting the LLM to generate these things statistically out of thin air. So what's interesting about this, IBM has actually come up with a model, and I think I have a link to it later. They're guaranteeing to their customers that the code that their models generate will not have copyrighted code. They're guaranteeing that the code that is generated will not infringe patents, and they're guaranteeing that it will not hallucinate within reason. And what it will do, unlike an LLM, if you ask ChatGPT a question, it almost certainly will give you an answer, whether it's right or wrong. And to paraphrase Peter Denning, it will be spouting nonsense. It'll be very confident and enthusiastic about its nonsense. The nice thing about these tools is when you ask it a question for which there's no way for it to find an answer in its knowledge base, it will say, I don't know, as opposed to, I've just solved P equals NP or whatever gobbledygook is going to tell you. So that is a huge step forward. And in fact, that's one of the great things you learn as a grad student, when to say, I don't know, right? As opposed to spouting nonsense. So very enthusiastic about this. Take a look at this link. This is the RAG description from IBM, and they have a nice little video that gives you like a 5-minute overview of how the technology works. But combining these types of approaches with LangChain, with chatbots, seems very promising to get much higher fidelity and accurate results. So what we're doing, again, this is something I'm doing with the SEI, is we're looking at how to do yet another form of discrepancy analysis. So we already looked at things like the AFMAN spec, is it consistent internally? But now let's assume you've decided what the guidelines should be for your nuclear safe program. How do you then check to see if the code that you're writing conforms to those guidelines, as well as all the other stuff that you need to conform to write secure code? So secure coding standards, C and C++, the MISRA compliance standards, and then be able to do essentially static analysis, use the technology, the chatbots, the generative AI to do this analysis. And what we're doing right now is we're comparing to see how well the LLM-based forms of static analysis perform relative to other static analysis tools that you might use, like Coverity or COQ or whatnot. And what's interesting about this, and I don't have time to go into this, but I'll provide you some links to other videos that talk about this in great detail. I've started building static analyzers using ChatGPT-4 to grade my student programming assignments. And what I'll tell you is most interesting about this, first of all, it works very well if you use the right prompts and use the tool correctly. But the other cool thing is when it doesn't work, if it doesn't find something that you know is a defect in that student code, rather than throwing up your hands and saying, gosh, I don't know how to make this work, what you do is you can engage in Socratic dialogue with the LLM. You can say, well, ChatGPT, you didn't find this mistake in the code, and here it is. And of course, the first thing it will do is it'll say, I'm so sorry, I apologize, I'm just a humble language model. Please take pity on me, because it's very obsequious. I can tell you how to turn off obsequiousness if you want. But in any case, what you then say is, okay, great. Tell me how to rephrase my prompt so the next time you look at this code, you get it right the first time. And it will tell you. And what it tells you is so cool. It almost always comes down to, I need more context. Those are like the most important words to remember when using these techniques effectively. Context is king. And when you give it the right context, it will in fact find those things. But not only is that interesting, but the fact you could engage in a dialogue with the tool. How many static analysis tools have you ever worked with where you can engage in a dialogue? How many times have you worked with an IDE where you get a syntax error and you're like, compiler, please tell me why I got a syntax error. And it's like, that does not compute. You never could do that before. So I think that's super exciting and paradigm shifting, paradigm changing. It's going to change the way we interact with computers. And it comes back to this generative augmented intelligence. We are working together, not trying to expect it to do everything itself. So we're doing a bunch of stuff, this again with my colleagues at the SEI, where we're basically taking excerpts out of the AFMAN spec, like should there be self-modifying code? No. Should there be dead code? No. Should there be code that has no bounds on the amount of recursion and so on? No. And then finding ways to do automatic checking with ChatGPT. And it's really cool, and it's very promising. And we think when we combine this with that retrieval augmented generation approach, it's going to be much more predictable. So it's another form of discrepancy analysis that gets other people involved. The other cool thing about doing things this way is you can get other people in the other stakeholders in the program involved. If you start writing code in your favorite static analysis formalism, very few people, even programmers, have the faintest idea what the heck's going on. You certainly are going to have a hard time getting the systems engineers involved, certainly not the program officers. But with the stuff that we're doing here, it's much more natural language. You can describe it in a way that a person can make sense out of, which is really the virtue of popping up to this level of abstraction. All right, next topic, one of my favorite topics, the discipline of prompt engineering. So what is prompt engineering? At a high level, it's basically how we structure our interactions with and program large language models, which are effectively computational systems, and then use them to solve complex problems via natural language. So that's the key thing, natural language. So the key point to remember here, and this is another video that you should take a look at that goes into this in more detail, the focus is on problem solving, not necessarily programming in the traditional way. So what do I mean by that? Well, I'll give you a couple of examples. First, in terms of how we do this as humans for programming. As I mentioned before, I'm often in a situation where I have some code that was done in a traditional way, tangling aspects together. So in this particular example, which you can see from this video, I had a bunch of code I wrote a long time ago where I had the timing logic interspersed with the business logic. And I wanted to extract out the timing logic. Well, how would I do that? Well, the old Doug would have sat down, gotten a Diet Coke and a pizza, and started refactoring the code by hand. The new Doug, who is perhaps more lazy or more clever, I'm not sure which one, went to ChatGPT and I said, here's a bunch of code. Please go through this code and extract out the parts that have to do with the timing and make them into general reusable classes. And then once you've done that, take the code that remains and refactor it so it calls those classes in a stylized way. And if you watch this video, you'll see how within like 20 seconds it did all that stuff for me. I really didn't have to I didn't have to write any code. I took code that existed and I had it refactor it for me, and it built all these other cool little tools along the way, which, by the way, it also documented, which was cool. So now I've got well-documented code. It's what I would have done if I'd spent a couple hours doing it, but it did it in just a few minutes. And you can watch the video. I show literally how I did it. So that's pretty cool. More broadly, however, this way of doing things, this type of problem solving, is extremely useful for other disciplines that don't want to be programmers. So back in the day, people come to computer science faculty at a university or wherever, and they say, I'm a biologist, I'm a physicist, I'm a classical civilizations professor or whatnot. I want to use computation in my discipline. Can you help me? And we say, sure. We'll teach you how to program in JavaScript. We'll teach you how to program in Python. That is not very helpful for the most part. People don't want to have to program in Python or, God help us, JavaScript. They want to apply computation to solve their problems. You see that in all these other disciplines. You see it in the military, right? You don't necessarily want your operators to be programmers. You want them to know how to solve things computationally and do computational thinking. Prompt engineering is the vehicle to allow that. Some of you, if you've been around as a programmer for a long time, are undoubtedly familiar with software patterns. So the Gang of Four book, I actually authored or co-authored a whole slew of books and papers on patterns for software, which are basically ways of looking for common solutions to problems that arise in a particular context. Well, gee, what a surprise. When you start using LLMs and you start interacting with them and programming them, there are patterns that emerge there. And knowing these patterns is really, really useful. This, again, is where the LLM skeptics, the people who try it once and give up, have really got it wrong. In fact, I've coined the term degenerative AI for people who take a one shot at trying to figure this stuff out, doesn't work, and they give it up. That's degenerative AI. They're degenerating what is actually happening. What you do when you do it the right way is you read the papers and other things that are emerging on prompt patterns, and then all of a sudden you become incredibly effective. I very rarely run into hallucination problems in my use with these tools anymore because I'm using the tools in the right way with the right prompt patterns. So we have a paper here that's been very, very popular talking about prompt patterns. It's very similar to patterns that we know and love from the software engineering world, just related to prompting of LLMs. A great example, very easy pattern, anybody who uses LLMs for any length of time will stumble upon this themselves, is the persona pattern, where you say, here's a document, here's the Air Force, the AFMAN 91-119. Read this document from the perspective of a acquisition professional or a safety engineer or a security engineer, and then you say what you want it to do. And it will read it from that perspective. Read this proposal from the point of view of a DARPA program manager. Find out where the Heilmeier catechism is not followed consistently. It puts it in the right frame of mind to anthropomorphize what's going on. And you will get results that are much more useful to you than if you just say, do this thing in the abstract. So that's an example of context. Remember, context is your friend. And these prompt patterns help you arrange the context. And there's so many cool prompt patterns. We don't have time to go through them all. This document talks about it. What we're also doing is we're documenting patterns for the other aspects in the lifecycle that are not just coding and testing, because we think that's where the bulk of this stuff is going to pay off quickly. Final thing on this point, a lot of people, when prompt engineering first came out 6 or 8 months ago, there was a bunch of articles that came along that said, all these people who are getting $300,000 a year starting salaries to be prompt engineers, that's a flash in the pan. These computers are going to get so smart, and the LLMs will get so smart, you just have to think. They'll have a brain implant, and you don't have to prompt engineer anymore, and they'll just be able to read your mind, and they'll just generate things that are perfect. That's completely wrong, by the way. Anybody who's ever watched the classic musical, The Music Man, if you remember Harold Hill, the huckster, he'd always say, think the minuet in G, right? So it was this think system. You didn't actually have to learn anything, you just had to think. Well, that's not going to save us. But more importantly than the fact that we're always going to have to do prompt engineering is, if you think about prompt engineering holistically, you realize there's a lot more to it than just the prompt. Just in the same way that when you think about software engineering, there's a lot more to it than just the programming. In fact, it's more or less the same set of issues. So if you really want to use prompts and LLMs for real in non-trivial large-scale acquisition systems that have to run for decades or work for decades, you've got to think about testing, maintenance, configuration management, version to version, being able to be release to release compatible. That's an engineering perspective that people really haven't looked at very thoroughly yet. But I think that is going to be very important if you want to make this stuff work for larger scale systems. Some of the systems I've been working on nowadays are expected to live 70 to 80 years. Imagine if we went back 70 or 80 years. Where are we? We're back to the end of World War II. Imagine if we had to limit ourselves today to technologies built in 1945 or 1950 or whatever, what a pickle we'd be in. Same issue. How do we think about things that live for very, very long periods of time? Holistic prompt engineering with the engineering part underlined is important. All right, so that's the first part of the talk. That's about things to think about with respect to the tooling. Second part of the talk, I want to talk about this other piece of the quadrant, which is the degree of AI-augmented system operations. So now we're trying to build systems that are going to be intelligent. And for the sake of discussion, let's assume we're not going to be using these AI techniques, but we could. So one of the interesting things that's happened over the past 8 to 9 months, all the oxygen has been sucked out of the room for all the other forms of AI except generative AI. I would hate to be a person working on computer vision at the moment because, first of all, nobody cares about that because they all want to do generative stuff, number one. Number two, if you look at what ChatGPT can do now with understanding images, wow, these guys are going to be in a world of hurt. It's kind of like the folks who used to do research on pen-based computing in 1999. Well, by the middle 2000s, nobody cared about pen-based computing anymore because we're all doing this, right, with our fingers. So a lot of the air has been sucked out of the room. However, there's an awful lot of other AI that we have to be aware of that's out there. And so the main point is I'm going to say is when we talk about AI-enabled systems, it's not just generative AI. So let's take a look at some systems that are actually doing AI augmentation in the system's operations. Great example, societal scale infotainment systems. Has anybody here ever seen The Social Dilemma? It was a movie from about 4 or 5 years ago that was talking about all the downsides with social networks and how these algorithms are there to basically make you addicted to being on your TikTok or whatever all the time. So there's other discussions about this in the National Agenda Study from the SEI focusing on societal scale systems. These are the ones that we all know and love, things like TikTok, or maybe not love, YouTube and so on. So YouTube is a great example of a societal scale infotainment system that is a content delivery platform that uses AI for all kinds of things, uses it for recommendations, captioning, moderation, analysis, advertising. What I do, just a quick little marketing blurb for how I'm using this in my classroom. Since the unrecorded talk is not worth giving, I record all my talks in my classes, and they come out in 5 to 10 minute little chunks. And what I do at the end of every session is I upload my videos to YouTube, and then I wait 5 or 10 minutes for them to generate a transcript. And then I go back over and I click a little button from something called GLASP, G-L-A-S-P. GLASP is a plugin for Chrome that will work with any YouTube video. And so you have a YouTube video that I just uploaded but not made public yet. I hit the GLASP icon. It takes the transcript, throws it into ChatGPT-4, and then it'll summarize the contents of the video. And then I come back and I say, please generate a 100-word summary of my video. My words. It spits out the 100-word summary. That goes into the description box for the video. I don't have to figure out what I just talked about for the last hour and a half. It remembers. It does a much, much better job than I could ever do of summarizing what I just said, because I would end up, it's hard for me to limit my summary to 100 words, but ChatGPT will do it. And then, of course, I look at it and I tweak it a tad just to make it be my voice. But what a huge productivity boost. It's great. And it's almost always perfect because it's coming from what I said, right? The context is well understood. And of course, the thing I think we care about here is mission critical systems, right? Where the right answer delivered too late becomes the wrong answer. And there's been a lot of interesting work. This is really where most of the research will be going or is going at the moment. How do you make generative AI work in a trusted environment? There's some interesting examples that you should check out if you haven't seen them yet. There's Palantir's AI platform. And if you watch the little video, they basically are using it to do mission planning for like special forces in exfiltration of people who are trapped in a downed airplane or something. I think about like the Serbia conflict where they got the F-16 pilot out or whatever. So really, really cool example. I don't know how real it is, but it's very eye-opening in terms of the art of the possible. There's also another platform from a company called Scale called Donovan. I'm not sure why they call it Donovan, but this is really used more for analysts as opposed to operators and mission planners, where they've got this example where someone is monitoring satellite imagery. They're noticing through sensors that there's a ship that's moving from North Korea to wherever, and it's got a high radiation signature, and then using their platform as they show, they're able to basically zoom in and re-queue various assets to get a closer look and all this kind of stuff. But when you watch these videos, again, whether it's 100% real or it's just where the world's going, it really gives you a sense of how the operator can work with this and program it through natural language programming. And it's very straightforward to do it. A lot of great prompt engineering, by the way, in those things as well. And the other thing that you'll see with both AIP and Donovan is this concept of model fine-tuning, where you take a large language model, a foundation model, and you combine it with something that is your documents from you. So much like the IBM technique we were talking about. So it's not just fabricating things out of thin air, it's fine-tuning itself on things that come in an operational context. We're doing some work right now also with folks at a nearby military base near Nashville, where they're giving us their orders that they use. Everything's in order, of course. And we're using LLMs to try to figure out how to do order generation and order analysis through large language models. Very, very cool. Obviously, AI-enabled software systems are going to be different from those that don't have AI. And there's a nice article by my colleague at the SEI, Ipek Oskaya, talking about some of these issues you can take a look at. One of the main things is the inherent non-determinism. So sometimes this is on purpose. If you make a chatbot, you want it to be somewhat non-deterministic because you don't want to have it just be like a rote answer where it spits back the same thing every time you ask it a question. That isn't very human sounding. Sometimes it's not what you want. If you want to start using AI to do your missile defense system on your ship, you might not want it to be all that non-deterministic because you want to make sure you can verify it, if nothing else. Big, big challenge. So we've done some interesting work on that in other contexts back in the day, actually back when I was in DARPA. The other big thing is emergent behavior. This is absolutely fascinating. So what you can do with LLMs, given the right context, is you can give them input they have never seen before, and they can do reasoning on that input. And it's sometimes called chain of thought reasoning and context-based learning and things like that. Ridiculously amazing. And I find that most useful for the work I'm doing with my classes because I'm giving people programming assignments or giving LLMs programming assignments that it has never seen before and asking it to do analysis that it never saw before. And it's coming back with things that are actually quite insightful. Of course, there's other things that get people scared about this, right? Does the system start becoming self-aware and then want to protect itself? Then we get into all the science, dystopian science fiction types of things. Another more technical issue is extreme dependence on data. So most of us in computer science, without overgeneralizing, have thought about verifying computational behavior, right? The algorithms, that's been the focus for forever. But in an AI system, the data and its cleanliness and its accuracy make a huge difference in the output that you can get. So how do you test the data? Well, the data science people have actually thought a bit about this, and the statistics people have thought a lot about this. Computer scientists haven't really thought about this as much. I went out and did some literature searches trying to find a link to testing data, and I could find almost nothing out there in the computer science literature, just not something that we think about as much, but that's super duper important for the future. And also designed for explainability and fairness. So one of the things you'll see when you start playing around with AIP and the Scale Donovan platform is they tout that their systems, unlike your off-the-shelf LLMs, can actually explain the reasoning of why they came up with the recommendations they did. And of course, you want to make sure, because you want to make sure that the courses of actions that are recommended align to mission goals, the rules of engagement, other policies, and so on. So I think we're going to see a lot of work on this. And this is important because unlike traditional software systems where you could go and literally find the piece of code that did X and then maybe fix it if it was not doing what you wanted it to do, in the LLMs, it's often very hard, if not impossible, to find the thing that does X because it's been trained statistically on all kinds of input, and it's difficult to figure out where that logic resides. For example, an LLM is very good about being able to do subject-verb agreement. Good luck trying to find where in the code it knows to say a versus an or plurals versus singulars. There's nowhere in there that's written down as a specific piece of code. Another big issue here is figuring out how we're going to augment the software engineering processes to do all the things we need to do for these AI-enabled systems. And I don't have enough time to talk about this in detail, but my colleagues at the SEI have written some nice articles about trying to field systems that use machine learning that keep those things in bounds. And there's also been a bunch of DARPA programs that are either looking at that or will be looking at that very soon to look at this as well. I think this is a great research area. In fact, if I had to come up with only 2 words to define the future of this field, those of you who have ever seen The Graduate, I have just 2 words I want to say to you. Assured AI, right? Instead of plastics. Classic line. So I think that is going to be huge focus if people doing research and applied research. How do we make these things trustworthy? And of course, that's important when we start thinking about how we're using this in DoD context, how AI will revolutionize warfare. Not everybody is equally interested in being ethical, right? I actually got a chance to meet Mark Espers, who was the SecDef a number of years ago, I think maybe 3 or 4 years ago, and he initiated a lot of the work on ethical AI and a lot of the guidelines and policies. The problem is, if the other guys aren't doing ethical AI, aren't you fighting with one arm tied behind your back? And I asked him that when I saw him, and he agreed. He said, that's a big problem. So we need to be careful how we use that. So how do we do this in our software processes? This is no surprise to anybody who works in the industry. Keep shifting left. This turns out to be much harder than you might think because you start getting into other people's rice bowls. So the testing and evaluation people want to get into the development side, but oops, you can't do that because they're restricted by policy and titling and so on, but that needs to happen. Something else we need to be able to do is figure out how to perform continuous quality assurance of these AI-enabled systems at runtime in a way that respects the other quality attributes. So it's not too hard, probably, to do this kind of runtime monitoring for YouTube or anything where you can wait a few milliseconds to get a response back and the little jitter doesn't make anybody panic. If you're starting to try to use this for ballistic missile defense on a shipboard platform or the stuff that we're seeing in the Middle East right now where people are getting shot at all the time, they need to be much more predictable and much more deterministic in how they respond. We've talked a lot about that in other parts of our national agenda, but we hadn't really thought about how it cross-cuts with the AI part. And combining those 2 things, I think, is going to be absolutely fascinating. There's some interesting work that's come out in the non-real-time part using something called AutoGPT, where basically it keeps feeding the results back over and over again until it either converges or you run out of time or whatnot. So there are some interesting approaches here, but I don't really think that these approaches have thought too carefully yet about the time-critical systems. So that is another huge area of research. How are we going to be able to integrate this technology into edge systems where timeliness matters, where you don't have all the processing resources that you would have in a cloud environment? I think that's a huge fertile area for researchers down the road. All right, so kind of wrapping up here and looking ahead, the study that we started out with 3 or 4 years ago was very useful, identified some things that are coming to pass perhaps faster than we might have expected. It's a fun study to take a look at. We were already starting on version 2 because we realized there's a lot more to be said. I think in some ways achieving trustworthiness, especially if you think about trustworthiness being generative artificial intelligence, in other words, get the human out of the loop for the most part, that is a long-term thing. We're not going to solve that problem anytime soon. Generative augmented intelligence, we're doing that now. This is the thing I was telling you about. There's some interesting stuff here about how IBM is trying to use this retrieval augmented generation technique to make it much more accurate and predictable so they can give guarantees to their customers, which is kind of exciting. The other theme here is we want to be able to focus on problem solving, not necessarily programming, although we are programming, we're just programming in a different way. And I did some real fun, there's a video here that talks about something I did with some of my colleagues recently. We had a faculty retreat, and everybody had to submit a 1-sentence blurb about what they wanted to be covered in the faculty retreat. So we had 35 1-sentence responses. Of course, we used ChatGPT to group them into 5 groups by cluster analysis. And then we had to come up with an allocation of the people to the groups. And so I asked everybody, send us your top 3 choices from this list of 5 or 6 choices. And because I'm lazy now, rather than sitting down there and doing it by hand or writing a program, I asked ChatGPT to do it for me. And if you watch this video, you'll show that when we first did it, I think as we talked about earlier, it used a greedy algorithm, which is what you would do probably if you didn't think much about it. You do it, take the first person, put them in a group that they want, take the next person, put them in a group. The problem is, as you imagine with greedy algorithms, you end up with people at the end who don't get into the groups they want. So I had a few other exchanges with ChatGPT as I asked it to try to rearrange the way it grouped things so everybody got into a group they wanted to be part of. And after a couple of fits and starts, it finally came up with a really clever randomness algorithm, which I would not have thought of, although probably if I just sat down and done it by hand, that's what I would have done, because I would just, monkeyed around with the stuff till it worked out, but it would have taken me hours. And so it was able to generate it. And if you look back at the transcript, which is what this video shows, I don't write a line of code. It generates a bunch of Python code, which I can look at. So it'll say, here's my work, want to see what I'm doing? And we converge in about 5 minutes on something and save me a ton of time, but I didn't write any code because I was problem solving, not programming, or I was problem solving with natural language programming. So everybody's going to be a programmer, right? That's the key theme. Even if you aren't a programmer with Java or Python or C++ or JavaScript or whatnot, you will be programming just like everybody's a touchscreen operator nowadays, even when you're 6 months old. So these papers give an indication of that. And here's an example of my latest programming. So I wanted to be able to generate an image, a pair of images that showed the difference between concurrency in theory and concurrency in practice. So in theory, with concurrency, everything lines up nicely, and you've got embarrassingly parallel processing where each thread stays within its zone. And of course, in practice, if you don't use the right tools, you end up with a big scrum of all the threads stomping all over each other. So I said, ChatGPT, please generate me a picture that has a bunch of dogs eating in an orderly way from their own bowls. And it generated that photo in like 10 seconds. And I said, please generate me another photo of a scrum of dogs eating from each other's bowls in a chaotic way. And boom, it generated that photo, or that picture. I was like, that's pretty darn cool. I was programming to get my visualization. I mean, can you imagine how long that would have taken to do the old-fashioned way? It's mind-boggling, right? I'm not that good of an artist. It would have taken me forever to do that. I wouldn't even have tried. And in like 20 seconds, I had these wonderful visualizations, which exactly got the point across, and everybody who sees it gets it the second they see that. So I think it's a nice example of how you don't have to be a programmer to get computation to do your bidding. The other thing, people sometimes say, oh, this is the end, programmers are going to be out of work. Think about the following. Ever since Fortran, people have been talking about the gloom and doom of how every advance in programming will put programmers out of work, right? Oh, we don't have to worry about register allocation anymore. No more programmers. The Fortran compiler will let the managers write all the code. Well, that didn't happen. C, C++, Java, Smalltalk, Ada, you name it, the 4th generation languages, 5th generation languages. Every time something comes out that raises the bar and raises the level of abstraction, rather than making programmers less relevant, We need more of them because people's appetite for cool products continues to rise. Same thing's going to happen here. We can focus, however, on the fun stuff, the creative stuff, the architectural stuff, rather than the nitty-gritty, low-level, mundane things. So maybe this will allow us to get rid of C. We'll see whether or not it gets rid of C faster than Rust does. By the way, it's really fun to run. This is a snippet of code from the obfuscated C code contest. And so it's fun to run that through ChatGPT and get it to explain what's going on. It usually figures it out much faster than a human can because it doesn't get distracted by all the gobbledygook that we get distracted by. So to kind of wrap up, we're still very much at the beginning. There's a lot of research we need, a lot of education, a lot of governance. Not entirely sure if the AI policies that are coming from the government are really going to help us or hinder us, but whatever. Let's leave that aside for now. But it's so easy to jump in. The barrier to entry is super low. It's fun to get started. Another thing to think about, taking a broader view, I asked ChatGPT, what are the most technologically transformational things that have happened over the past 1,000 years? And it generated something which I think is pretty good. The printing press, that was a disruptive thing. The steam engine, electricity, computers and the internet, right? This is, quite a long time. And of course, I threw this one at the end because this is where my talk's going. But I really do believe we are living in an absolutely pivotal time. This is a transformational era. It's exciting to be doing computational stuff because we are really able to help influence how this turns out. That's really fun. That's exciting. So you can enjoy the time of your life. But sort of one more sobering thought, or two more thoughts. So one thought is, just as we have had a digital divide for a long time, which is people with internet access and those who don't, which is usually based along socioeconomic issues, we're about to have a similar problem, but even worse, with people who are savvy with this stuff and those who are not, which also may or may not cut across socioeconomic boundaries. I am endlessly amazed at my colleagues, all of whom are computer scientists, how few of them actually know how this stuff works and how much fear, uncertainty, and doubt and misconception and confusion there is in my community. If software people and computer scientists don't know, the average person on the street hasn't the faintest idea what's going to go on. And I think that's a big concern. And I know from my own personal experience over the past 9 months or so, I am hundreds, if not thousands of times more productive using this stuff. I can take on tasks and projects I wouldn't even have attempted. Leaving aside, they would have taken me a long time. I wouldn't have tried them because it would have taken me forever. So a couple of months ago, I wanted to teach myself how to do modern microservice architecture programming for asynchronous database access. And I'm like, wow, do I have to go back and get a master's degree in data science or whatnot? No, I sat down with ChatGPT, and within a couple of days, I knew a lot about this stuff, enough to teach my class, and enough to be able to bootstrap myself into something I never would have tried without this technology. What's interesting about this is even though there's this opportunity for a chasm, there's also a great opportunity for a leveling of the playing field. And that's because nobody on the planet, with the exception of maybe Sam Altman or whatever, has more than 6 to 9 months of experience with prompt engineering. If you guys don't need to worry about this, but if your family members or if you have kids, your kids who majored in classical civilization or sociology like I did when I was an undergrad, if they suddenly decide they want to go back and get retrained to learn to code, they'll take a boot camp, 24 weeks later rather, they'll emerge to knowing how to do web dev with JavaScript and TypeScript and React, JS or whatever. And then they'll go out and they'll compete with people who've been doing it for decades. So they're still at a disadvantage. But there's no competition. If you want to learn this stuff, you don't really have to have a computer science degree. You can become a very, very good prompt engineer very quickly with almost no investment. Like you don't have to go out and buy an expensive license. Maybe you have to spend $20 a month to get ChatGPT Plus. This is going to give a lot more people a chance to play in a level playing field. So I think that's actually kind of exciting, gives a lot more opportunity for innovation. And the other really cool thing, this is speaking very personally, I've had the fortune of going to grad school in UC Irvine, being a professor in St. Louis, and around me were high-tech companies that wanted to do things I was doing. So in Irvine, I did a lot of work with telecom companies. In St. Louis, I did a lot of work with McDonnell Douglas and Boeing. But when I moved to Nashville, there wasn't anybody there doing high-tech stuff. I mean, down here they're doing high-tech stuff, but up there, no high-tech stuff. What's cool about this is now, and so as a result, if I wanted to teach people how to do real-time embedded programming with my middleware, there was nobody around who gave a darn about that. With the generative AI stuff, every discipline, every sector, every domain needs this for something. And all of a sudden, we can help anybody out because everybody needs to get up to speed with this stuff. So it's so much more fun to do work where there's a very eager audience to learn this as opposed to having to go to some obscure place and do something that only a handful of people care about. So I think it's really exciting from a technology point of view because becoming an expert at something really pays off quickly. Okay, so that is the end of my talk, and then we can take questions.